So I want to introduce you guys to accessibility and accessibility within React. But before we do that, I'm going to talk a little bit about myself and let you guys know who I am. My name is Jeffrey Johnson. I'm a senior software design engineer here at SAP Concur. I've been at SAP Concur for about 3 years. Fun facts about me, I actually sold my first freelancing site when I was 11 to the Mason County Democrats. I got them off front page for anybody who knows what that was like. I've also worked on, it's been mentioned a few times, the core UI library within Concur. And so every single day I've been working with accessibility. Right now I'm heading up a team to address accessibility issues with the Concur at a rapid rate. In my spare time, I spend my time hiking like many Washingtonians. I also love walking with my dog, who is up here on the slide and takes up the majority of my life, as well as spending time with my family. All right, so before we get started talking about accessibility, I want to introduce you guys to this idea of universal design. Universal design is something that you guys encounter every single day, whether you're aware of it or not. And so universal design is defined as design of buildings, products, or environments to make them accessible to people regardless of age, disability, or other factors. So what does that look like? So a few good examples. Door handles, I think, are a phenomenal example for universal design. I think over the past like 50 years, not a door handle expert, we've seen them change from the circular knobs to being more of these levers. These levers are easier to use because you can push them down with your elbow. They require a low level of effort, and they're pretty straightforward in how to use. Also, they can go up or down if you've never noticed that before. Light switches is another perfect example. You don't have to tell people how to use a light switch, even regardless of differences between countries. Light switches are pretty easy. They've also been shifting from what we know as a normal light switch to these kind of flat panels. So another example of universal design. Some other ones to think of too, building entrances. You've seen some probably really bad wheelchair ramps into buildings. However, you've also seen in newer buildings, like the one we have here, we don't have ramps. Everything is flat, and there's no barrier to entry when you enter the building. Another perfect example, playground equipment. No one has to tell a child how to play on playground equipment. You know how to use the slide, you know how to use the jungle gym from an early age. So it is universal in the sense that you can learn it really quickly. Drinking fountains is the last one I threw on there. Everyone knows how to use those. So what makes something universal? So it means that it's equitable, so everybody can use it. It's flexible, so it's easy to use. It's simple and intuitive to use as well, so you don't have to read a manual on how to use it. You can perceive information really, really easy about it. So for light switches, if it's on or if it's off. There's a high tolerance for error. So in the case of the door handle, if you push on it with your elbow, you miss it and it flings right back up. That's fine, you just try it again. And it requires a low level of physical effort. So those older door handles with the knobs, you had to be able to squeeze and bend. That was a lot harder to do versus using your elbows, a little bit easier. And then size and space is another thing to consider when talking about universal design. We'll skip that one for now though, because it doesn't necessarily apply to us. So how do we use universal design on the web? I think I'm gonna move this a little bit here. You guys here. I can hear as I turn my head, it's cutting out, so hopefully that sounds a little bit better. So what is universal design on the web? How do we design in a similar manner to building a light switch that everybody knows how to use? Well, we focus on building flexible user interfaces. We allow users the choice of how tasks can be completed, so they can complete something either by using that easy door handle with your elbow or grabbing it with your hand like you see typical people use. We also need to support assistive technologies so that universal access is available to all of our users. And we also should be providing feedback often. A lot of the mechanisms you've seen with light switches, playground equipment and whatnot, you know how to use them because they communicate to you. The light switch tells you if it's on, if it's up, off if it's down, so on and so forth. So let's dig deeper then into what the practice of web accessibility is. So web accessibility is defined as websites, tools, and technologies that are designed and developed so that people with impairments can easily utilize them. There's a bunch of different impairments to consider. Auditory, people who are deaf or hard of hearing. People who face cognitive issues, that can be various learning disorders. Neurological issues, or also known as chronic, or also seen sometimes as chronic illness, can be something that limits people on how they use a website. Physical limitations, those who are missing arms, limbs, are a little bit harder to use a website, especially one that has crazy shortcuts where you have to click something. a little bit difficult to use if you only have your right hand available. People who have speech limitations, they also can have a hard time using the web, especially voice-activated sites, which are on the rise right now. And then people who have visual issues. This could be people who have full vision loss, so they're using assistive technologies to read out websites, or it could be people like myself who are colorblind and just can't see the color red very well. And then to access a website, a user might be using some form of assistive technology. I know I often use a technology that helps me change the red into a color that I can discern. So what are some of those technologies? Within the development world, a lot of people talk about screen readers, those who tools that essentially audibly, which I will show you, audibly explain a website. Keyboard users, people who are not using a mouse, so they're all tabbing, moving around that way. Or low vision users, or color contrast users. Quick show of hands, how many of you wear glasses, have contacts, or have had LASIK? Yeah, so all of you are technically considered accessibility users. You are using tools, for example, glasses or contacts, to be able to see it a little bit better. This is no different than a user who is using a screen reader to be able to browse a site. You have to use glasses to be able to browse the same website. Other cases that are not considered nearly as much are users who have low vision and use magnification. They zoom into your site really, really close because it's really, really hard to see things. I feel like I'm slowly landing in this category. Users who use dictation software to explain what they want to do. So they actually talk to the computer, tell the computer they want to scroll up and down. Actually, if anybody caught WWDC, this is actually a new feature in Mac OS that's now standard in Catalan, the next version that's coming out. There are users that also utilize braille displays, so people who don't necessarily like using a screen reader or want a different way to interact with content actually have single line braille displays. It's kind of hard to see, it's right up here in this upper left that has little raised bumps that pop up and down. There are people that have cognitive impairments, use other forms of technology that I don't even know. And then even situational limitations are also coming into play when thinking about accessibility. That can be riding the bus and not able to hear a video and opening up YouTube and being able to read the captions. You're not a hearing impaired user, but in that situation, you are impaired enough that you can't hear and you're actually able to take advantage of assistive technology. Another example for that is I often hear the example of a woman who recently has had her first child, or actually any child, and they have that child in one hand. They are now situationally limited where they can only use their right hand. That's a case that Microsoft really likes to bring up, and I think it's a really, really common case. For me, it's my puppy in my left hand and trying to browse the web with my right hand. So how do we handle all those cases? I just dumped a ton of things on you guys. So if you're a web developer and you've gone through testing, you're probably typically testing with a mouse. So how do you test for all of those different cases we just went through? It's pretty difficult. So the way that I personally go about it, and the way that we're going about it at Concur, is we actually focus on accessibility standards. So there's benefits to using these standards. They allow you to focus on to meet a minimum bar. They simplify the onboarding of how do you start to make things accessible. They help guide your development direction and help you do the right thing. And over time, as we all work with these standards, they actually become the default. So we're no longer having to think about different ways to make something work for a specific user. We instead just follow the standard, and it works for most people, if not everybody. What are some issues with this though? It can be difficult to interpret. Some of the standards that I'm going to show you guys, it takes a lot of time to go through all the documents to know them end to end. I'm going to suggest you don't need to, and you can just pop in and out as you need to find what you need to find and be off back into your development way. They can be lengthy when compared to something like success criteria and defining how a user should do something. The standards have way more information and can really look like an academic novel sometimes. And you can feel like you need a degree to make any sense of it. I know being an accessibility expert, it took me a good 6 to 9 months before I even really felt like I understood the standards documents to the point I could jump in and just start working with them. I do not have them memorized. There's no way that I could ever memorize them, and I'm opening them on a daily basis. So let's talk about some of those standards. So the most common standard that you guys will hear about is called WCAG, sometimes pronounced Wcag, sometimes pronounced Wcag. It's all the same thing. It stands for the Web Content Accessibility Guidelines. And so the Web Content Accessibility Guidelines was built in 1999, and the first one that was published was WCAG 1.0. Those of you who are probably familiar with images need alt tags, this is that standard that really, or that specification that brought that into the norm. So we went about 9 years before we got WCAG 2.0. A lot of things happened between 1999 and 2008. Gmail launched. we started seeing document sites slowly kind of disappear and be really more focused on dynamic websites. Social media was just coming into play. And so the web really evolved in this 10-year period. And so WCAG 2.0 aims to really tackle that and make dynamic websites more accessible to all users. And we'll talk a little bit about how they go about that. The next spec actually just came out last June, or I guess it was June of 2018. I started seeing it around January. This is WCAG 2.1, and you can see another 10 years has occurred since the launch of 2.0. This really encompasses touch devices. Between 2008 and now, the iPad came out, the iPhone came out, we're all using multi-touch devices, multi-form factor devices. And so this specification really aimed to kind of append WCAG 2.0 to then cover those users and make sure that their needs were also served. WCAG 2.0 is backwards compatible with WCAG 2.1 is backwards compatible with 2.0. So if you were compatible with 2.1, somebody asked you if you're compatible with 2.0, yes, you are. And it's not a breaking change. So how do you understand the WCAG? It's broken up into 4 major components. I won't dig too deep into the WCAG, but I think it's important to understand the different components and kind of how they have a role in organizing this spec. So the acronym that we all use is POUR, P-O-U-R, which stands for perceivable, operable, understandable, and robust. Perceivable really just means your information should be easy to convey. You should be using P tags. You shouldn't be hiding a bunch of text inside of spans. You should be using things that you're able to actually interact with and that are not hidden from users. There's no complication to be able to access things. Operable really means that everything that you're putting on the page should be usable by the user within that web standard. Sorry, I have some notes here because there's a lot of little things to go through. So user interface components, for example, such as navigation, should be nested within a navigation tag. That allows the user to quickly be able to find that navigation and quickly go to the page they're looking for. Information should also be understandable. This really means you shouldn't be hiding things behind acronyms. You should be using clear, concise language as much as possible, as well as you should be labeling all of your components so that a user understands if they're in the first name field or they're in the last name field. And finally, robust really is an encouragement as well as a short specification on making sure that what we develop will last over a long period of time. It's not worth building something if in 2 years the specification completely changes. We have to come back and rebuild this all again. So WCAG really encourages us to create websites or web applications that last over the long term. So how do we go a little bit further into web applications? We've talked about how to make documents a little bit more accessible in basic websites. That's where the Web Accessibility Initiative's accessibility initiative spec called ARIA, which some people may or may not be familiar with, came into play. ARIA also launched with WCAG 2.0 in the year 2008, and it helps enhance HTML to convey status to the operating system and the assistive technology. Things like a custom drop-down menu, being able to say if that menu is open or closed. These are things that ARIA aims to tackle. ARIA also helps to label things correctly. So if you say, for example, we'll show you an example of a button with a download icon. We'll show you how to label that correctly so a screen reader can use it. ARIA helps augment HTML roles that already exist in order for you to be able to make a more dynamic web application. Not all ARIA tags work with all roles, so definitely worth following the WAI-ARIA standard. That is in the resource slide on the very end. So if you take a look afterwards, definitely check that out. So let's talk about some common accessibility mistakes. This is where I really hope to kind of give you guys some tools so you can go back to your respective web developer jobs and think about things that you can improve to make your site a little bit more usable. So this is a really common one. So color contrast, I think, is actually the most common accessibility issue that you see on the internet. This text here is actually too dim for some users that have low vision to be able to see. Another good example sometimes is, in rooms like this, sometimes the projector bulbs are about to go out. If your contrast is too low, it's even harder to see. So let's take a look at this. So WCAG states that we need to meet a contrast ratio between the background and foreground of our content of 4.5 to 1. I'm not a designer, but I do know a little bit about colors. So in this case, I used a very non-designer color scheme of gray and white. And you can see I set my background to solid white, and then I picked a shade of gray. This shade of gray evaluates to 2.85 to 1. So it's pretty faded, it doesn't look too awesome. So let's go ahead and update that. We're gonna just go a couple shades down, make it a little bit more towards black, and now we're gonna reach this contrast of 5.74 to 1. Let's take a look at what that looks like. So you can see the example on the bottom is much more vivid. It's a lot easier to see. So for anybody who's dealing with color issues, or having a hard or working with low vision, this is going to make it a lot easier to see than the bad example up at the top. Another common mistake that we see is using color to solely convey meaning. So you can see on the left, level of courses is conveyed via color. So you have red, yellow, and green. I know what ones are red, don't worry, somebody show me. And when you're looking at these, you know, it kind of makes sense if you're somebody who can see color, and you absolutely can tell what one's harder, what one's not. I, however, cannot. I can tell they're a shade of brown, so I kind of fudge my way through it, but we can actually do better. Just by simply adding the text on the right to each one of those cells, we can convey what that color means. And by simply adding just a little bit of English text, you've now helped a large group of users, like myself, to get confused very, very easily when you just simply use color. So I'd like to show you guys some screen reader stuff. So this is a perfect example of a read issue that occurs inside of a screen reader when there's no label present. So I'm going to go ahead and hit play here. We're going to hope the audio works.
Heading level 4, get software now, button.
And so you heard, it read the heading that said get software now, and then it landed on that button. And that button has an icon inside of it, which is really just trying to convey download. If any one of us that's sitting here that's fully sighted saw that, we would have an idea that meant download. However, that's not the right way to go. So,
get software.
There we go. So, just because this is React, showing you guys what this could look like in React, you see we have that header here, we have the button, and nothing else. So there's a way we could fix that. By simply adding an ARIA labeled download, we're actually going to enhance that button quite a bit, and let me show you how that sounds.
Heading level 4, get software.
Of course it cut out right there.
Level 4, get software now.
Please?
4, get software now, download button.
There you go. All right, so you can hear now, after the fourth time, I swear it works the first time. As a user is navigating around, if you're using magnification software and you don't have the ability to see things very well, that button is now explained much more clearly and you understand that it's a download button. We didn't have to make sacrifices to using an icon, but instead we were also able to augment our UI so that our UI was a little bit more clear for users. Another example for this, I talked about this a little bit ago, is missing alternative text. I want to show you what this sounds like to a user. Imagine that you do not have the ability to see and you're browsing through a site. You're really excited because you maybe collect sewing machines. Also props to this person for being a blind seamstress or seamster, if that's a word. And so you hear what this sounds like. It's a pretty hard to use experience.
Heading level 2, my collection, /626,537_1000_1_1_800.jpg image.
So ask my coworkers, they hear this all day long coming from my computer. It's not the coolest thing to listen to random numbers for file names. We don't do a very good job reading them out. Webpack, as we just saw, kind of has its own way of creating file names. And so we want to make this a little bit more usable. So this is what the code initially looked like. You can see there's that image as well as with that source there that was read out to us. So simply by adding an alt tag, which you can see here.
Heading level 2, my collection. Red sewing machine image. Next.
Oh. And so hearing that red sewing machine image, that adds a lot of context. You don't need to see this sewing machine. You don't really care what kind of sewing machine it is, but now you have an idea that there's a red sewing machine present on that page, and that gives you an idea of what you're looking at. So let's talk about some assistive technologies. I demoed some for you there. I was actually demoing VoiceOver. We'll show you a couple others. So screen readers are really kind of the most common assistive technology we all build for. If you're just starting out with accessibility, I highly recommend just start working with screen readers. It gives you an idea of how to look at your web application a little bit differently. But there's a lot of different screen readers in play. This was taken from WebAIM, which is an accessibility group based out of Utah. They do conduct a survey every 2 years on the most popular screen readers that are out there. You can see JAWS, NVDA, VoiceOver. They're really the top 3. JAWS, we'll show you a JAWS demo here. But JAWS stands for Job Access with Speech. It was one of the first screen readers that came onto the market. NVDA is a screen reader that's free to use, that's been primarily developed open source. So highly recommend checking that out. That's up and coming. JAWS is very expensive. VoiceOver, if you're on a Mac, is totally free. So highly recommend you check that out as well. And then you can see there's a variety of other screen readers. And then shout out to Microsoft. They started a new screen reader in October of 2017 called Narrator, which is doing very, very well. It's just in its infancy. So I want to show you guys what it looks like to use a screen reader on a day-to-day basis we've shown you what some of the errors look like, but what do these users interact with the website? What does it look like when they use a website? So I picked the BBC, figuring a news site's gonna look pretty decent. And you can see this software also, I made a quick note down here. You can download a demo of it. It runs in a thing called 40-minute mode. Once you hit that 40 minutes, it simply requires that you restart your computer, which can be a little bit of an annoying process to be rebooting all the time. However, if you plan your testing well, this works out. It rarely bothers me. So let me show you what this looks like. I'm going to play and pause this as we go. Hopefully the audio doesn't cut out, but I'll try to fill in the blanks.
Accessibility links heading level 2. BBC banner region. Significant accessibility.
So you can see right off the bat, there's actually some special content that's showing up on the BBC's website. So as you're navigating around, it's actually giving screen reader users a little bit of extra content. You can access this without a screen reader as well.
Item link. BBC navigation region. Home news link. Sport link.
And so this is just tapping around the, of course I messed it up. This is just tapping around the page to browse the different headers. But there's another way that we can use it. We're all used to using the tab key to move around navigation elements. Screen reader users have more tools than just the tab key. Oh, come on.
BBC navigation region. Home news link. Sport link.
So you can see, I'm going to have to fill in the blanks here. You can see I hit the H key. There's a variety of different keys that are set up that allow you to browse via HTML5 elements. So screen reader users of the JAWS variety tend to hit the H key to navigate via heading quite a bit. They also can use the B key to navigate via button, as well as they can browse sections and articles. Any bit of context that you add with HTML5 really helps these users be able to navigate your site a little bit better. I'm gonna go ahead and skip past this one a little bit. So the other tool to take a look at too is another tool called Zoomtext. So for users that face macular degeneration or they have really bad, really poor to grading vision, like myself, they will actually have a circle in the center of their vision, which makes it really difficult to see things. So they end up using their peripheral vision to navigate around. So a user that's using Zoomtext, as you can see here, they navigate around by dragging their cursor. Their screen is always zoomed in. In this case, I'm zoomed in to
2.5.
Yep, 2.5, 2.75. I believe it goes all the way up to 10, so you can actually get down to where you just see that tab there. And as they want to navigate around, they drag their mouse left and right, and it scrolls the screen for them. They can also pick different color cursors, cursors that are different colors. You can add a crosshair so that you understand where your cursor is. You can change the dog bone. So there's a lot of different ways that you can augment this assistive technology to browse the web. And you'll hear even the screen reader I have set up, or the Zoomtext I have set up right now also has a screen reader built into it, so it's conveying anything it can audibly as much as possible. So we're in a React.js meetup, so how do we build and test for accessibility? I've shown you all these different ways to test things. We can't be doing this all day long, or we're never gonna get anything done. So I would propose the first way to really tackle your accessibility issues right away is to use linting. So for those of you not familiar, linting provides real-time feedback for code that you write, and it can catch errors in your code in almost real time. Most coding languages have their own version of linting, or have their own linters. In our case, we use ESLint for React. And accessibility linting provides that real-time feedback for errors that you may possibly make with your markup. So I'll show you an example of that. So I just threw together a pretty bad example. If those of you who are using divs for on-clicks, shame on you. But this div has an on-click on it, which has an alert that just is simply called, that says you click the homepage div. You can see down here towards the bottom, I actually showed the two linter errors where it tells us that visual non-interactive elements with click handlers must have at least one keyboard listener. There's one user we forgot about. We just thought of mouse users, we didn't think of keyboard users. The other piece, the other issue below, it says static HTML elements with event handlers require a role. We need to assign that role. So there's a way to fix this. We could actually add role equals button here, and that would make sure that the user knew that it was a button, or I would even propose to go a step further and just use syntactic HTML and use the button tag itself. All right. So the last thing I want to talk about, so we talked about linting, one way to kind of fix your code in real time. So how do we start testing our code faster and start digging a little bit deeper into what some of the issues we might already have on our website? How do we fix those? So we can lower development time by fixing these issues early. It's estimated that fixing accessibility issues now in development can save you up to 100 or 1,000 times the cost of having to go back and rebuild your entire site from scratch and put that cap back on and relive all those days it took to build whatever you built. And there's many tools that can help provide a general confidence in what some of these blocking issues are. The sad bad news is accessibility is subjective for users that are using accessibility. So depending on the assistive technology, the impairments they face, we're actually only able to catch about 17% of accessibility issues using some of these tools. Some of these tools, we're going to go over Axe here in a second, but Wave, AMP, and Google Lighthouse are also 3 really great alternatives. So I want to talk to you guys about Axe Core. So Axe and Axe Core is a project made from a company called DQ. They're based out of Ann Arbor, Michigan. For those of you looking for other meetups, the Seattle Accessibility Meetup, one of the main contributors for that, Marcy Sutton, used to be a former developer of Axe, and she did a phenomenal job. So Axe works by detecting common issues caused by other package changes that you've made, and it's able to work either in the browser, which I will show you here shortly, or in most JavaScript testing frameworks. So it's easily integrated with Jest, Jasmine, Mocha, and it's JavaScript. It's super easy to bake in. They've also built some add-ons for those of you who use Puppeteer and Selenium. So that's another way that you can test using Axe and Axe Core. And by setting up these tests, you're going to catch your issues early. It's going to catch things like incorrect labels, labels not being associated with inputs, detection of missing keyboard navigation, as we just saw a second ago, as well as it's going to validate that you're using the right ARIA and roles together, something that I even still mistake to this day. And it's also going to perform some generic HTML validation. Make sure you're not breaking any generic HTML rules. The more HTML rules we break, the less the assistive technology knows how to interpret them. So let's go ahead, and I'm going to do the same thing Mark did. I just want to show you guys what Axe looks like. So I'm going to go ahead and mirror my display, and this is the same BBC website on a different date, running the Axe Chrome plugin. This plugin is super easy to use. All you have to do is just pop down here and hit the Analyze button. And give myself a little bit more room here. And you can see on the left, it's going to return a variety of issues that Axe was able to detect. If you can get this list down to 0, massive props to you. I've only been able to find a handful of websites. One is the Government of Canada, which actually has no issues. Most sites have at least 1 or 2 issues, as well as it's worth being aware. Sometimes this can't throw a false positive. So I'm going to jump at color contrast. You can see one issue here. We have 4 issues that says elements must have sufficient color contrast. On the right, it actually shows me that this item we're going to be looking at has a 3.35 contrast ratio. We're aiming for 4.5 to 1. And so what is this element? So I'm actually able to highlight this element. So you can see the element highlights here. And I think looking over on the right, you can see that Thursday, June 6th is a lot dimmer. So it's not meeting that contrast. Just simply lifting it up a little bit would make things go a long way. We can also navigate through these issues where you can see, here's another contrast issue on the button for editing your weather. And then as well as some contrast issues with this blue background and the text color they chose for this heading. So Axe can really help you understand some of the issues that you're already facing today. It's free, so everybody should download it and at least run it a couple times on their site. All right. So I want to encourage you guys also to think about accessibility as something that there's always room for improvement. The accessibility practice is always changing. Assistive technology is always getting better. There's new assistive technology, as we just saw at WWDC, coming out all the time. And nobody's 100% accessible. But the only way to get towards a more accessible world is to always be working on accessibility and striving towards 100%. I often say this is very similar to security. Nobody's 100% secure. We all like to think we are, but there's a hole somewhere, and we're waiting for someone to find it. I guarantee you, if you feel 100% accessible, there's something or a use case that you have not considered, and we're just waiting for that user to speak up and let us know what they need. So striving to meet 100% compliance will go a long way to really increasing the accessibility of your web application, as well as growing your user base. Accessibility, oh sorry, you guys are looking at this awful display there. Accessibility users are estimated, and we believe this is low, to be about 15% of the US population based on census data. Those of you who are wearing glasses, you are not considered in that, since most likely when you filled out the census, you did not consider your glasses to be an accessibility device or assistive technology. So these are users that identify using screen readers, zoom tools, magnification tools, so on and so forth. And we believe this is low because you have to self-identify. And as we know, everybody who has to self-identify, that rarely do we get the whole sample base for that. So with that, I hope that all of you can now make better, more accessible web applications. Thank you very much. If you guys have any questions, feel free to reach out to me on LinkedIn. I'm a heavy LinkedIn user, and I would love to chat with you guys. So thank you.